So today I don't have a handout for you to fill in, but what I have created here is the note that I usually do with my classes, my grade 10 academic classes, in terms of summarizing our concepts related to factoring. So what I have here is kind of like a flow chart or a little diagram that this is what my brain is thinking when I do factoring questions, especially if it doesn't tell me what type of factoring I need to be doing. And in the grade 10 academic class, we tend not to do that. We expect that you guys can kind of look at the patterns and figure things out. So our first step in factoring when we're looking at these things is that we always want to check for a common factor first. Okay, so I have that with a double exclamation mark here because it's really important. It makes your other type of factoring easy because sometimes there's more than one type of factoring in a question. So remember, for common factoring, I just have a simple example here of common factoring. What we're looking for is a number that would divide every single term and a variable that appears in every single term, or variables that appear in every single term, and we always take the lowest power of that. So when you're creating your note on this, you might want to put little side notes in terms of what this actually means if you need to. So I've got my example here. I found that 3x is my common factor. So 3x I divided out, and when I divide 3x out of every term, I was left with an x squared minus 9x minus 4. Now that is a three-term polynomial. It is a trinomial. So my next question that I'm asking myself once I get that common factor out, if there is a common factor, is how many terms are there? So in what was remaining up in the above example, I had 3 terms. And in fact, when I looked at my 3 terms, I have a 1x squared, a minus 9x, and a minus 4. So in terms of 3 terms, that would lead me down this path to a simple trinomial. Okay, and then from there, that's where the simple trinomial is the one with a 1, x squared plus bx plus c. We'd be looking for 2 numbers that add to the negative 2 and multiply to the 1 times negative 15, which is negative 15. And I found that my 2 numbers were 3 and negative 5. And we know the simple way to do that is once I find my 2 numbers, my 2 factors will be x plus 3 and x minus 5. And if you were to actually do a quick check on that, you could actually expand that, do x times x and get x squared. The x multiplies the minus 5, that's minus 5x. The plus 3 multiplies x, and that's plus 3x. And then the plus 3 multiplies the minus 5, which is minus 15. And this is a way to check your factoring. If you collect like terms now, we get, I goofed. What did I goof at? Oh, that was a plus 3x. We get a minus 2x and a minus 15, which was my original question. All right, so that's how you can check. I'm just going to erase all my markings here because that makes it really hard to read. Okay, so we're always looking for that. Now, in terms of the example that I had up at the top with the common factoring, if I look at that particular trinomial, I don't think that one will factor. If I try and do my adds and multiplies too, I'd be looking for 2 numbers that add to negative 9 and multiply to negative 4. And if I try that, 1 times 4 would multiply to negative 4. But knowing that 1 has to be positive and 1's a negative, and my bigger number has to be my negative because I'm adding to the negative, this combination would add to negative 3. And if I try 2 and negative 2, that adds to 0. So there is no combination that this will actually factor any further. So that one is as far as it can go. Okay, now moving on with that, once you've done any kind of possible common factoring, then when you're asking how many terms there are, it kind of leads us into the 3 different examples that we looked at. We looked at cases with only having 2 terms left, and if there's 2 terms, it's potentially that difference of squares. And remember, a difference of squares is when you have a perfect square, take away a perfect square, hence the word difference, and then squares. And that, when we factor it, it gives us conjugate binomials. Binomials that look the same, they have the same terms, except one has a minus in between and one has a plus in between. So I just did a quick example of 25x squared minus 49. Remember, square root the first, it goes at the beginnings of the brackets. So if I square root 25x squared, that gives me my 5x squared. It goes at the beginnings of the brackets. If I square root my minus 40, or well, ignore the negative, square root 49, we get 7. It goes at the ends of the brackets, and then one's a minus and one's a plus. Okay, so that's our quick way of factoring a difference of squares. So again, if there are steps there that you want to add to your summary, by all means, this is your own summary to make it yourself. I've kind of just given you bare bones here. All right, if we have 3 terms, there's 3 possibilities that we can come across. It could be a simple trinomial, which we found there is a shortcut for those simple trinomials. If you find, or when you find your 2 numbers that add to the correct thing and multiply to the correct thing, you can go directly to your factored form because you only have a 1x squared. So you know the first 2 terms, the first terms in each of the binomials are going to just be 1x each. And then these 2 numbers, the 3 and the minus 5, plus 3 and minus 5 fit in here. All right, so that's where that's coming from. If you do it by decomposition, if you do all the steps in between just like we do with tricky trinomials, that's okay too. It takes longer. And sometimes we know that time can make things go a little, like if you can be efficient with your time, it can save you more time for some of the trickier questions that you might come across. All right, the special case of the simple trinomial is if you had, and I'll erase some of this marking up afterwards, if you had a perfect square. And the perfect square is when you recognize that first term to be something you can square root, and the last term something you can square root. The perfect square has the exponent of 2 on the outside of its factored form. We square root that 4x squared, it becomes the 2x. We square root the 9, it becomes the 3, and we take the sign from the middle. So that's basically what I have here. My first term to the exponent of 2, plus that 2abx, and then plus the b squared. The thing with that is we always want to check to see, does the middle term come out of this? If I take twice the product of my 2 terms, do I get that middle term? So 2 times 2x times 3, 2 times 2 is 4, times 3 would be, 4 times 3 is 12. That would give me my 12x. And I've got the sign from the middle, which is my minus, so that would work. All right, so a good thing to check every time just to make sure that works. I could potentially give you an example where it looks like it should be a perfect square, but then turns out to not actually work as a perfect square. And then you have to go into the tricky trinomials, which are the ones that we don't necessarily have a perfect square on the first, like 6x squared. 6 is not a perfect square. 3 is not a perfect square. This is where we're looking for the 2 numbers that add to the middle and multiply to the products of the outside. So 6 times my negative 3, if I do my 6 times my negative 3, that's where this negative 18 is coming from. And I found 2 numbers that would do that. I broke it down and did my decomposition, broke down the 7x into these 2 pieces here, and then I paired up for a common factor. And that's exactly what we do when we have 4 terms. So if we come down this path, we have 4 terms. That's when we try that grouping thing. We look for things that pairs have in common because there's nothing totally in common because we already did the common factoring up at the top. All right, so hopefully that all makes sense. This is sort of my brain pattern when I'm thinking about what kind of factoring I'm going to be doing. And one of the questions that I've assigned out of the textbook has all the types mixed together, and in fact some of them are 2 types where you do have to do common factoring and then another type of factoring on top of it. So just be mindful of that when you're working on your practice questions today. And the other thing to remember is that the reason we do this factoring all comes down to that factored form of the quadratic, and the factored form of the quadratic tells us important things about the parabola. So if you forget what that is, take a moment to look at that. I'm going to get you later on, whether it's today or whether it's the next class, to review that information and start putting this into play. How is it going to help us actually solve problems? Because that's the big purpose of this. Why do we do this? We do it to help us solve certain types of problems. Okay, so make yourself a summary here on this, and then good luck with the practice.